So in this particular example, I'm gonna demonstrate a Turing machine. The Turing machine reads of ones and doubles the input at another part of the tape. The tape language only has zeros and ones, and we're gonna show you two examples. So here we go. So here we see the stack as the actual score numbers, which you, in the initialization purposes, you can see here. For example, these type of values. You can also see them in binary. LR is where the input header is, the tape pointer is going to be. Symbols are the symbols that we clicked on. So let's begin. With two defaults, let's start with the first one. So in the first one, you see that the tape header is pointed at the 0, and it's going to double these ones to 6 ones. So let's begin. So the thing is, in our denotation, we say that this stack, the top of this stack, is the header of the tape pointer. So this thing points to this thing, which is always this top of the stack. And this one is always left of the tape header, tape pointer. Let's begin. So the thing is, the game you're basically playing is, what do you see here? Well, we see a 0, so we click a 0. In that sense, it is user interpreted and user driven. But by this user drivenness, we can simulate a Turing machine. Here we go. Now move one to the right, and it'll pick one off, and then move to the right, and then eventually copy them. And that's copied twice, and we see a 0, so we go back, and we see a 1. Now I wrote about how XIMPEL isn't able to remember what you pop off here to push on here, so we need to interpret that. So we are gonna. So this one is always here on the left side, and this number is always on the right side. So we see a 1 and a 0, so it's 1 pop 0. It's the state we need to click. And this is 0 pop 1. So now you see that the tape just moves, but that's basically because the pushing and popping of the stacks here happen in such a way that it just seems like it moves. But if I would have pressed anything else, then this whole tape would have been corrupted. 1 pop 1, and it is 1 pop 0, 0 pop 0, and where it started. It is a 0 0, 1 1, 0 1 1. It just goes past it, and now it copies it. 0 0 1, and this is a 1 pop 1, 1 pop 1, 1 pop 1, 1 pop 0, 0 pop 1, 1 pop 0, 0 pop 0, and here we go. 0 0 1 0 1 1 1 1 0 and 0 0. So 1 pop 1. And we have a 0 pop 1 pop 0. Oh, we have that problem. Yeah, so I should have programmed it slightly better, but getting the symbol so I can actually click. Yeah, I think this right? I hope so. Yep. And then we get to 0. Program is done. The input should have now been doubled, and that's exactly what you see. You see 6 ones. So the computation is done. And that's also the case for if you do 4 ones. Just to show. One pop 0. It's also a really good educational tool how to simulate a Turing machine by 2 stacks if people ever want to learn. 0 pop 1. 1 pop 1. 1 pop 1. 1 pop 0. 0 pop 0. 1 pop 1. 1 pop 0. 0 pop 1. 1 pop 1. 1 pop 0. 0 pop 0. There we go. R. This is a 1. 1 pop 1. 4 times. 0 pop 1. Kill the symbols. 0 pop 1. 1 pop 1. 1 pop 0. 0 pop 0. Oh wow. This is... I think something went wrong. Yeah, something went wrong. Let's see if I made a mistake or if it really is program. Let's see. I have to do this all over again. 1, 0 pop 0. Wait, is that correct? Am I just making simple mistakes now? So I have a 0, 1. 1 pop 0. 0 pop 1. 1 pop 1. 1 pop 1. 1 pop 0. 0 pop 0. One pop 1. 1 pop 0. 0 pop 1. 1 pop 1. 1 pop. Oh, this flips. That's not smart in terms of design. 0 pop 0. Gonna kill you guys. Kill the symbols. Let's see. Where am I? 1 pop 1. 0 pop 1. Oh, really? Wait, so the 0 pop 1 in state 5. Am I pressing the wrong? Oh, I should have remembered the state. Then I could debug it. Okay, wait. Let's create a debuggable state. Oh, 0 pop 1, 1 pop 1, 1 pop 1 pop 0. 1 pop 1 twice 0 pop 1. Oh, did I click a 0 pop 0? Is that it? That's interesting. So sometimes I make a mistake, or there is a mistake. One pop. One pop. One pop. One pop. 0. Okay. This is gonna be my first debug state. Let's see, stack 1 is this. Stack 2 is this. Refresh and go to it. Oh, but it jumps to state 1, but this jumped to state 0. Mm. 1, 0, 1, 1, 0, 0, and 0. 1, 1 pop 1, 1 pop 1. Oh, okay. This is 1 pop 0, 0 pop 1. I think I see what I'm doing wrong. 1 pop 1, 1 pop 0, 0 pop 0. What? This is the second debuggable state. So that if I make any errors again, debug 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 0. Yeah, goes back. 1 pop 1, tap. 1 pop 1, 1 pop 1. Again, 1 pop 0, 0 pop 1, 1 pop 0, and a 0 pop 0 state. Yeah, okay. Save this state for the debug. And this is how we debug. Let's see. Wait, what? Wasn't it the case that I just already was at number 3? Wasn't I? Wait. Oh, this is default 2. Oh. Yeah, wait, okay, just there you go. Yeah, 0, 0, 1, 0, 1, 1, 1, 1, 1, 0, 0, 0, 1, 1, Bob, 1. Right. 1 Bob 0, 0 Bob 0, state 6, and then 0. Yeah. So I just made a mistake. That's really the case. So you can also see the 4 is doubled. Wow, this is a way longer video than I intended. But this is how XIMPEL is a Turing machine.